Hi guys, this is my 5th time filming this, so bear with me. This video is about residuals, and so I chose a problem on page 199 of our textbook, so flip to 199, and it's R3, number 5. So I'll kind of read it to you. So Japanese cherry trees tend to blossom early when spring weather is warm and later when spring weather is cool. Here are some data on the average March temperature in degrees Celsius and the day in April when the first cherry blossom appeared over 24 years. So you have a little you have your data in the book, and you want to plug that into your calculator. And the first part A, is to make a well-labeled scatter plot, as well as describing the function, form, and strength of the relationship. So try that out, and then pause it, try that out, and come back, and I'll show you how I did it. Okay, so in your calculator, you plug the data, as I said, into L1 and L2. So stat, edit, here's all the data. And then to get the scatter plot, you press second stat plot, or y equals. And you press the first one, make sure that it's on. Make sure that the type is the dots or the scatter plot. On your x list is L1 and your y list is L2. Then press graph. So here's the scatter plot. And if it's not exactly in the frame, press zoom, zoom stat number 9, so that it looks like this on your calculator. And then you want to draw that. So here's a little mini graph, and it kind of goes. This is just rough. X and Y. And the Y is days in April. And the X is the average temperature in degrees Celsius. And then the direction is negative, because as the average temperature goes up, the days in April goes down. So as the X goes up, the Y goes down. That means negative. And then the form is linear. The data kind of follows a linear pattern. And then the strength, the points, they stick pretty close to a line, so it's fairly strong. Okay, so the next part of the problem is to use technology to find the equation of the least squares regression line, and then interpret the slope and the y-intercept. So those are kind of the interpretation sentences we were talking about in class. So try that out and then come back. So to do this, go into your calculator again, and you want to go stat, calc, number 8, which is line reg, and not number 4, ax plus b. You want to do a plus bx, because that's the least squares regression line. Let's enter. And then our calculator is a little bit different, but for x list, you want to put L1. For y list, put L2. And then no frequency list, make sure that's blank. And then you want to store the equation in y1. So you can do the little shortcut Leanne taught us, alpha trace y1, but this calculator is different. So you have to do bars, y bars, function y1. So that it also works on our calculator, but it's a little longer than the shortcut, obviously. Then there's your linear regression. So you have y equals a plus bx. Your a is 33.12 and b is negative 4.69. So linear regression, and this is predicted value. So predicted value of y is equal to 33.12 minus 4.69x. that's the least squares regression line. And then as for interpreting the slope and y-intercept, so the slope is negative 4.69. This is the slope. And then the A is y-intercept, 33.12. So as for the slope, you do for every additional x, which in this case is degree. So x. Every additional degree, the temperature or the y is predicted to decrease because it's negative, but if it was positive, if the slope was positive, you'd say increase. So slash decrease, but in this case decrease, by the B, so 4.69 days, which is the unit of y. And then as for the y-intercept, in this case, when you interpret the y-intercept, you set the x equal to 0 in context, but in this context, x equals 0 doesn't really make sense, so the y-intercept interpretation has no meaning. Okay, so the next part is to predict how many days in April before the first cherry blossom if the average March temperature was 3.5 degrees Celsius. So try this out and then come back. So this part is pretty easy. For this, all you have to do is use the equation that we got. And for x, just plug in 3.5 degrees. So we can do that in the calculator real quick. So 16.705. So 16.705 is the predicted amount of days if the average in April before the first bloom, if the average temperature in March was 3.5 degrees Celsius. So the next part is to find the residual for the year when the average March temperature was 4.5 degrees Celsius. So go back to the data and look for the data where the temperature in the temperature to first bloom is 4.5 degrees, and then find the residual, or the difference between the predicted and the actual. Okay, so a little correction. I think I said it was the difference between the predicted and the actual, but it's the difference between the actual and the predicted. So the equation you use is y actual minus y predicted, or y minus y hat, and the hat stands for predicted value. So if you went into the data, you would find that it showed when the average temperature was 4.5 degrees, that led to 10 days. and 8.2. But our linear regression predicted something different. So our linear regression again. You want to plug in 4.5 degrees. So go back into the calculator. In our calculator, you can just move this down and change 3.5 to 4.5. So 4.69, 4.5, and that gets you 12.015. So the y predicted is 12.015. So then to find the residual, you just do the actual, which is 10, minus the predicted 12.015, which gives you a residual of negative 2.015. There we go. Okay, the next part is use technology to construct a residual plot. So basically you have to find all of the residuals for each of the data and then plug that in and graph it. So try and do that and then come back. Okay, so for this there's a couple checks. So the first, you should make sure that your residual plot shows no obvious pattern. And the second, the residual should be relatively small in size. So after you make your plot, you can go into window and make sure your y-min and your y-max aren't too big. They shouldn't be like very large numbers at all. So the process. So you want to calculate a residual for each point, and we went over that. So it's y actual minus y predicted. So in your calculator, your L2, the data in your L2 is the y actual, and then you want to plug all of L1 into that equation. So you do y1 a function of y1, L1. So, and then store that in L3. So I'll go through that. So you do L2 minus, again, there's a shortcut of alpha trace, but in this one you got to do vars, y vars function y1, and then put parentheses and put L1, enter, and then store that. So store L3. So now you have stat all of the residuals in L3. So then you need to graph the residuals against x. So this time, instead of where the scatter plot we had x as L1 and y as L2, now you want to make y L3. So you do the same thing, second stat plot, the first one, make sure everything is good, and then do second 3 L3, graph that. Oh, and it's showing the line. I'm sorry, 1 second. Graph, and then zoom stat. And that's your residual plot, like that. So, and then describe what you see. So basically, it should show no obvious pattern. The residual plot shows no obvious pattern, and they're relatively small in size. So again, you can go into window, and the y-min and y-max are bigger than 10, so they're relatively small. So last part, find and interpret the value of r squared and s in this setting. So I'll give you a second, and then you can come back and see if you were correct. Okay, so r squared is the, also known as the correlation squared, is the coefficient of determination, and it's always going to be a number between 0 and 1 because it's a percentage. So to find it on our calculator, it's a bit different than the computer calculator. So on our calculator, you just press stat calc lin reg, and then you do x as L1, y as L2, and you find r squared, which is 0.72. So, and then there's an interpretation sentence for this. So 72% or r squared of the variation in the number of days, which is your y, before the first bloom in April can be explained by the linear relationship with the temperature or the x variable. And then as for s, s is the standard deviation of residuals. So to find this, you do stat calc and then 1 bar stats. So I think I can show you this. So stat calc 1 bar stats. and make sure the only thing you have in there is L3. And then you do the SX. So SX is 2 point, I don't think that's right. Oh yeah, it is 2.96. And that's your standard deviation of residuals. So yeah, that's it. Thank you. Yeah.